Hello, everyone. After 4 minutes of a technical break. So the good, I'm here. The bad, technical. The ugly, the slides. But yeah, let's move on. So hi, everyone. I'm Kamil. I work at the Guild. It's a great group of people. I'm really proud to be there for, I guess, almost 8 years. Such a long time, but still excited. Our core product, I would say, or like my main focus is actually GraphQL Hive, which is like a schema registry, observability tool, also a gateway, and our solution for like GraphQL Federation in general, also for monolithic schemas and so on. Yeah, and I was working for past few months, both on the Hive gateway, but also on the Apollo Federation audit, which is our like tool to make sure that, first of all, our GraphQL gateway is compatible with the Apollo Federation specification. And we never had a tool to actually measure if something actually supports the Apollo Federation. Now we have one. We put it into the tests. Here you can see the results. It's actually a CLI that you can use. It has like 170 tests across 40 different subgraphs, supergraphs. Yeah, and you just run it against the gateway of your choice or like custom solution. It doesn't really matter. And you get the result, detailed result with all the, like basically report of all the tests, why they succeed, why they are not. But I'm here to talk about the schema registry. Actually, if you work with GraphQL, you will eventually find yourself looking for a solution to prevent breaking changes. But if you're using Apollo Federation or any solution for federated GraphQL, you will need something that will actually compose your subgraphs or like services into a larger thing, which is called in Apollo Federation a supergraph. So at this point, you might find yourself looking for an existing solution, or you would think, oh, it's actually easy to implement one because you have all the resources and so on, so you can just do it on your own within your CLI, within your CI/CD pipeline with a bit of this and that I will cover later. But what it is exactly the schema registry, right? So the schema registry, so the usual workflow when dealing with like Apollo Federation is that you have like a subgraphs that you need to publish somewhere, right? And at some point, the composition logic kicks in, so you need to like merge those, validate those, and produce an artifact called a supergraph, which is kind of like a gateway document that explains the relationship between fields and types across different GraphQL APIs. You also need to store it somewhere. Yeah, in Apollo Federation, it's called a supergraph schema, pretty much. And that's exactly what your gateway needs. So if you happen to use Apollo Federation, that would be my example in this talk, is on the gateway level, you need to be aware of all the schema, ownership of the fields and type, where everything belongs, and how you communicate to those subgraphs, right? So that's what the gateway part in the schema registry is about. Also, in terms of like continuous development, continuous delivery, and continuous integration, here's like a complex example of what the usual pipeline looks like. So you first build the code, generate the subgraph schema, you check the integrity with other subgraphs, and then you have like a success or failure depending on a bunch of steps, right? One of those steps is to validate if the subgraph schema is actually correct. The other one is it actually checks if you can compose it with other subgraphs without any issue. Yeah, and some other, it depends what you actually need, like linting, or like generate the changelog, or do some custom logic, or actually detect the breaking changes. And it's all complex, but you might think, oh, it actually could be a lot more simpler. I don't need this complex setup with my company. I can go, I can start small and grow. Why should I have all that complexity? And yeah, there are some simple implementations for some like a concept of a schema registry, I would say, or like a solution to actually have subgraph and supergraph and like stitch it all together. So first solution would be to just use the introspection, right? Why should I have some tooling around it? How can I just grab a schema from a subgraph at runtime at the gateway level and compose it into a supergraph, right? The other one is CLI-based, I should say. So you can use a solution, like one is from Apollo. They have like a CLI called Rover, which actually allows to compose subgraphs into a supergraph with a single command, which is amazing. Our solution is this Hive CLI. Then it should also work, right? When you deploy a subgraph, you can actually compose it, ship it to the gateway, job done, right? Another approach would be, like, first of all, you need to store the artifacts somewhere. And the other approach, which is kind of interesting, is like using Git repository to store those artifacts. And it kind of makes sense because it's like literally a registry of your changes of the schema, kind of. So it's, from my opinion, a really natural fit and a nice solution. The only problem is that, yeah, it's simple, the introspection. But what if a particular service is down, right? It's unavailable for some reasons. Then you cannot really compose a supergraph because you don't have all the schemas, right? What do you do in case when, I don't know, you deploy a new subgraph, right? You need to notify the gateway. So you either implement the simple solution, which is polling, or you introduce a custom mechanism like a PubSub, or you simply redeploy, right? But how do you deal with the actual issue with this approach? It's not really that, oh, something is unavailable, or like, how do I notify the schema? This is easy, right? You can just retry. But the issue is that if you happen to introduce a backwards incompatible change, or you actually break the composition, but it's already deployed, what do? You roll back. You have some mechanism to actually do it automatically. It's already too late, right? All the requests cannot be served from that particular subgraph because it's outdated, and it's not composed with the rest. Here, it's the CLI approach. I took 2 screenshots from Reddit, GraphQL Reddit. 2 people actually talked about using the CLIs to compose the supergraph, use a file watcher, mount the file in the container, and so on and so on. And this could work, but like, yeah, and this could work, actually. Like, I don't see any issue with that. It's just a lot of complexity, I must say. And you also need to think about the storage. Where do you put the supergraph? How do you fetch the schemas of the subgraphs? You have to have a list somewhere that says, oh, I need to pull this, and compose it in the supergraph, right? The third option actually is like a combination of CLI and the storage would be the Git repository. So you can see here's the compose shell script that actually does the composition. You see that on the root directory, there's also like an artifact that is read by the gateway that then actually pull the supergraph GraphQL from a branch, and the branch could represent the production environment or like staging environment and so on. Yeah, and you also store every needed information for the subgraph, like a location, the name, and the actual schema, right? But I really think that Schema Registry is not really about storing the schemas. It's also but let me explain. So to me, those are the core concept of a Schema Registry. First one is optionally composition, which handles the validation, merges the subgraphs into a supergraph, and provides an artifact for the gateway, right? The second, and for me, one of the most important parts is actually detection of breaking changes. You want to prevent your schema, introducing, you want to prevent introducing new changes that will actually break your existing GraphQL consumers. So that's one, the second thing. And also, there is no Schema Registry without the gateway, right? So you have to integrate it somehow. And when building your own Schema Registry, you need to think all of those 3 options, right? So the composition, in short, is just like you basically check if the integrity between subgraph is correct, if they can be merged, and if you also perform a lot of validation, actually. But the core rule of the composition and federation in general is to make sure that every query path can be resolved by those subgraphs, because you don't want to end up having like a runtime errors that could be prevented at the validation phase, right? So the breaking change. Let's talk about breaking changes. So what do I even mean by a breaking change? You can have like a deleted field, rename type, but in general, everything that is like backwards incompatible with your operations or with the previous state of the schema might be called a breaking change, right? So I grouped them into 3 groups. First, there are actually 3 solutions on my mind. First one is actually too strict. The other one I call safe, but you're actually blind. And then the third one is actually the smart approach that I will explain. So first one is actually about, this is where I started doing, like, at the Guild when we did a tool for detecting breaking changes. We call it GraphQL Inspector. It was pretty much a diff between the before and after state of GraphQL schema. Then we collected like a list of changes, ranked them by, rank them by 3 levels, I believe. It was like a breaking, dangerous, and safe. So we can do the same. The issue with that approach is that, yeah, it's like, OK, it's simple. It's enough for your use case. That's the job. But the issue is that it's actually too safe. So what if you have a field that is removed, but it's not really used, right? So it will always, whenever you make changes, and when you make changes to your schema very often, it will actually block your pull request, which is not that good. And also, you lack a lot of information. So even though the field is deleted, you have no idea where it's used. Is it even used? By who? Where can I find the schema? So it's a big issue. The next approach would be like a combination of the first one with a sprinkle of basic data. So it's basically you still perform the static analysis, compare the before and after state. You get a list of changes. You see those that are like breaking, and then you have some kind of like a storage and like usage reporting of your GraphQL API, where you store which fields were used in, let's say, past 30 days, right? It's a simple solution. I did that in one of the companies already that we work with at the Guild. And it works. It's just that does the job. If your if your goal is to actually prevent breaking changes, like to prevent breaking used pieces of schema, it will do the job. The issue is that, yeah, you have less noise in your CI. Detected breaking changes are actually, in fact, breaking because those fields were used. But the issue still is that you don't have any context of the usage of those fields. You don't have the operation. You don't know who is using that, how often, in which environment, and so on. So that's why I call this this method. You exchange too smart to actually safe, but blind because you lacking information. So be smart. And in this approach, actually, this is what we do at GraphQL Hive, which is you have the static analysis, you have ranking the changes, you ignore unused fields, and so on. But you actually give a lot more context to the user. So you share what are the GraphQL clients, at what versions, what are the timestamps, how often it's used, in which in which deployment environment, and so on and so on. So you give people an actual information to make a decision whether this field can or whether this change should be accepted at the pull request level or rejected, right? They have all the knowledge. The only thing that's left is like with this approach, you don't really see a field that is there in your code, but it's barely used, right? Because it's just the traffic, right? Is it not used? Like, for example, it could be like a delete account mutation, right? It's there. It's, if your product is really good, then, it's barely called, right? So it actually makes the traffic analysis and like ranking fields by used, unused, and how often. It makes sense, but not in all cases. And you also put yourself what I call the rabbit hole of feature requests that I will cover later. So the fourth approach is to actually taking this smart approach into next level, and it involves breaking changes. It involves the persistent operations. So with persistent operations, what we do actually in Hive is like we group, whenever you persist an operation into Hive or your schema registry of choice or custom solution, you actually group that by the deployment of your app or like deployment. It could be like a web application. It could be like iOS version 1 to 3, whatever. And basically, if you have any traffic from that particular application, you know that every single field that would register through those operations, they cannot, even though they did not have any traffic, they are still there, could be triggered at any point. So yeah, it adds obviously a lot of complexity. Actually, me and Lauren will do a workshop about it tomorrow, I believe. Yeah, so you're very much welcome. The third part of the core pieces that I called about the schema registry is the actual gateway integration. So you see here that obviously the gateway delegates the request, blah, blah, blah. But the core part here is the one between the gateway and the registry. So if you want to have some kind of like insights and analytics and actual schema usage, what the gateway does is actually report those usage information to the registry, but also pulls the supergraph from the registry. So this gateway registry, this is the cycle. About the rabbit hole. So if you want to really build your own schema registry, then you will face the issues with like detection of breaking changes and so on. If you want to add more analytics, that's also fine. But at some point, people will ask you about more features, right? One of those features could be to actually have like a schema explorer. If you have like, I don't know, 400 subgraphs or like 200 or 50, doesn't really matter, then it's like a shortcut of like Command F to look for a field or a type. It's just like, it won't work, right? And you also want to like, I don't know, navigate through the schema, see who owns which pieces of schema, how often they are used, and so on. It's just a really nice and useful feature that at some point you might want to have it in your organization. So another feature that most likely people ask you for to implement is to see unused pieces of schema. Our schemas are always growing, right? It's hard to really clean up the things that are no longer used. You have a process of deprecating, but then you also need to track, when should I deprecate? And you should deprecate when you clearly have no traffic, right? So that's, another feature request that you might get. Next, you want to see the deprecated pieces of schema. You want to communicate to teams that, that field was deprecated and, they will probably ignore you. So you have to be proactive and like, go to those teams and say, this field will be, removed in, let's say, I don't know, 30 days from now. And to get to this point where you see those fields, you need to have a view or a filter that actually shows you, oh, those are the fields that are deprecated, right? And the list grows. So you could like imagine this is your like Jira ticketing system, and like Q1 you have like, I don't know, a person that says, let's introduce a scheduled removal of deprecated fields. It just makes so much sense, right? You have like a deprecation that will happen in like, I don't know, 3 months from now. We have a deadline. So let's automate it. Let's connect the deprecation of the fields to actual operations. And like if an operation uses a deprecated field, this operation belongs to a particular team. So let's notify the team through, let's say, a Slack notification and so on, that this field will no longer exist in, I don't know, 7 days from now and so on. And the list grows. At some point, you might actually reconsider your schema registry and just use an existing solution because it's just like a huge overhead. About the challenges, so there are some difficulties when building your own schema registry. We did it with Hive. We did it before even starting Hive with doing consultancy. So the first of all is like, you have data, right? So you need to pick a database. What kind of data do you store? Like a schema for a subgraph, information about the subgraph, also the supergraphs. You need to store it somewhere. If you want analytics, you need to, even to detect the breaking changes with giving context to people, you need to store usage information of your GraphQL API somewhere. You obviously need like user accounts, projects, deployment targets, and a lot more. Where do you do it? You think, maybe I will do it in Postgres, right? Like my company already supports it. It's a natural choice. You can't go wrong with Postgres, right? It can handle everything. Yes, but don't use Postgres for analytics. We've been there. We actually use Elasticsearch. It did not work. Why? First of all, with Postgres, you may fall into a trap of having like indexes because it's a relational database. So then the insertion, especially if you have like, I don't know, even like 50 million requests per month for like billions, then ingesting so many data can actually flood your database. Storage size. So you need to delete some data after a while. Like you cannot store it forever. In Postgres, there are no really good mechanisms to do it. So your schema have to grow infinitely, or you have to introduce some kind of cleanups to do it. And it just adds complexity to your custom solution. The same stuff applies to the data compression. Postgres is not really good. And if you have like schemas that are basically the same except a few differences in a field or like an output type of that field, then you just keep using the same information over and over the time. And also Postgres is not really performant if you have a lot of rows and you have to, I don't know, calculate like P95 based on a few factors. So I suggest to use a database that is really good for this specific use case. At Hive, we use ClickHouse. It's very easy to set up. So in case you want to have like your custom schema registry, I think this is the obvious choice. The only problem with that solution, like one of many, but like your database team will probably be not aware of it, of ClickHouse, so they have to learn it. And your company most likely does not support it yet. So it's like a big cost to pay. Data ingestion, perfect. It can handle like billions of rows per month on a single instance. No issue with that. It has a built-in support for like time to live at row level. And the data compression is extremely well. So if you store the same schema 100 of times, it will actually clip the diff, I guess, of it. So basically, instead of like 100 schemas that are exactly the same or fairly similar, you store just one instance, kind of. Query performance, also really fast, as long as you have a well-defined database schema. About the database schema design. So as I said, we started with Elasticsearch because we thought, why not? You can, it's actually maybe makes sense. But then we realized that it was like, the queries that we made were taking about like 30 seconds and 10 seconds on average. After adopting ClickHouse, actually the latency went down to 1 second and often less. But due to poor schema design, it actually went back to 30 seconds and 10 seconds. Doesn't matter once we get more and more traffic. But thanks to recent optimizations, it went back to 1 second. And you might say, oh, it's actually not relevant to me. But if you happen to have at least 1 billion operations, then this is the scenario that you most likely will follow, except the Elasticsearch. If you want to understand, or like if you are curious, like how we deal with ClickHouse at GraphQL, what was our journey and how we actually store and track GraphQL requests, we have like a nice article that you can visit on our blog post. We also happen to collaborate with ClickHouse team to actually explain why we moved away from Elasticsearch to ClickHouse. And about the analytics, like how do you report that a particular schema, let's say a field or a type or like any piece of schema was used, right? How often, by who, and so on. So we need to establish some kind of protocol. Remember the cycle I mentioned? So you have the gateway and the registry, and they have to talk to each other, right? So the way they talk needs to be established. You have to have some kind of structure. You also have to happen on the gateway level some kind of logic that actually extracts pieces of information, put it into reports, aggregates them, and send it to registry. So that's another level of complexity. And also you need to, which is even harder, I would say, process those. Like first of all, have an endpoint to receive the data, process it, and ingest it into the database. So here's the structure that we use at Hive. So we have, this is the usage report. It was actually, we have a definition for it. We have like let's say a protocol that is open, and then other implementers. Like for example, we have a client for Ruby that is not maintained by us yet. And and they basically follow the same structure, and it allows us to have the same format for reporting usage operations. Basic information. So basically you store an information about the request, which is the operation body and the name, schema coordinates that were involved in this particular GraphQL request, execution details, client information, whatever you really need. But this is what you will eventually need at your schema registry that you're building, which is, you can see it's already like, you have to deal with it, you have to maintain it, you have to make sure that it's like the data that you insert is actually correct. The other problem that you might say, oh, it's actually not affecting me, is the scale. So imagine having like, I don't know, 50 instances of your gateway, and you at some point, like, I don't know, tweak the aggregation of data, and you send the usage reports in an interval, but this interval is actually either 10 seconds or, I don't know, 2,000 2,000 requests in one batch, right? You still have, I don't know, like 400 requests, 400 users reports sent every second, for example. And because you do a lot of processing and so on, 400 requests per second may be not enough, even on a single instance, to receive and process and have like real time or like a sub few seconds data in your system. So you have to keep up with the amount of requests that you get, or tweak this and that. But like you would have to eventually have like more than one instance of a service. So yeah. Also, if you happen to have, like, for example, if you start to ingest data and you start to recall GraphQL request, and you ingest it, let's say, into ClickHouse or Postgres, doesn't really matter, it might work until it, it dies. So for example, you can ingest, I don't know, 100 million requests. It's working fine, but at the scale of 1 billion, which is like, at the end of the month, you see that like the query times becomes like extremely slow. The storage is just blowing up, and you have to deal with it, right? So you have to you either shut down the service, and you are blind again. You don't really can use the schema registry because you cannot process the data. So you need to fix those, and those will happen, and those will bite you at any time. You obviously will have to have like permission system for your users. You obviously will have to integrate your existing auth provider with the solution that you're building, right? So it adds another level of complexity. And if you want to publish schema to your registry, you need to have like tokens, right? The tokens need to have corresponding access. This access may be super granular or just write and read, but it's all up to you. You have to think about it. Yeah. Other kind of complexity, I would say, if you happen to have like multiple deployment environments, and for sure you have, then it adds to the cardinality of your data. It increases the storage and so on. If you happen to have more than one gateway or many different projects in your organization, you also have to deal with it. So you have to group data into projects or like targets, however you call it. And also, if you happen to have like many users that you need to organize and give granular access to this and that project, it also adds a lot of complexity, and it's really not an easy task. And if you want to introduce features like schema contracts or like filter the schema somehow based on conditions or like tags in Apollo Federation, and then you also have to implement this logic from scratch. And it's also not, it's not hard, but you need to think about a lot of things. So those were the technical challenges. The operational challenges are, like, first of all, if you happen to have the schema registry now, it becomes like the critical point of your infrastructure, of your architecture. Whenever the schema registry is down, you cannot really publish, so you cannot make changes, you cannot deploy, right? If you have a storage for the supergraph, you also have to make sure that it's like highly available. In case it's not, then your gateway cannot really run, and that's an issue. So you have to, first of all, maintain and overlook the database. That's one thing. And when you happen to have the whole system, you need to upgrade the components, right? They're getting updated. You need to, like, I don't know, introduce a new one, and so on. Also, if this is the core and like critical part of your architecture, on-call people will have to be somehow involved into the registry part. They will need to be aware if something is down, where it is, what is down, why it's done, and so on. And then you obviously need to deal with bugs and unexpected behavior. That's like super obvious. So to summarize, yeah, if you happen to have your own schema registry, you're building from scratch, you obviously have full control over it. It's like extremely tailored for your needs. You can grow as big as you need. You don't have to have all the feature at first, right? But as I said, like there will be feature requests. People will ask for, oh, we have so many data that we can use and automate and have different processes and so on. And then we'll actually bring up the development effort of your team, right? At some point, maybe you will have to have a dedicated person that is like really just looking over the registry, or a whole team to manage both the gateway and the registry, right? You also, it will bring up the cost. It's hard to measure, but like if a person needs to be, more and more involved into the schema registry part, then it's actually taking the time of that person instead of, doing something else. This is what she or he has to do now. Also, because it's a new solution, it's used only by you. The risk of failure is actually much, much higher because it was not tested yet. Like if you have, I don't know, if you're using the existing solution, that it's something that is already tested by a lot of people. And yeah, in my recommendation, really, and I'm biased, but I really, really mean it, is to use an existing solution. There are plenty that you can use. First of all, you get continuous updates. So if somebody has an idea, this idea might be worth even to you, even though you yet not realize it. So those would be the features that I showed, like with proactive cleanups or like scheduled deprecation of fields and so on. And if you happen to use like an open source solution, you can actually contribute back. If not, you can like apply and do a feature request. And it actually, you can benefit from other people's experience. So if they have an issue, if the solution is not working for them, they will actually go back to the maintainer, we'll figure it out, and then you start from with the knowledge that the solution got from from feedback from people. And every time somebody will say it's easy, it's just a few hours of work, it's actually a multi-sprint task that you will later on, even if it's done, you will have to fix a bug. The bug will take, I don't know, 3 days or like a week, or you will have to like migrate the data that you have. That will take at scale of like billions of operations. It might take even a week to migrate, and it's just and it's just not a good thing to be in. And that's it. So if you happen to have any questions, I know I say a lot if you happen, but if you happen, then please ask them. Yeah. And if you don't have any questions, I'm like, at the Guild's booth. So yeah,